Hi, hello everybody. I'll try to be very straightforward. So this is the academic talk for today. I'm going to talk about simulation. I'm going to try to explain you what we are doing at the National University of Ireland, Galway, in the IRIS group. IRIS stands for Informatics Research Unit for Sustainable Engineering. So here a brief summary of the talk. I'll talk about the IRIS group. And I'll particularly focus on two projects, mainly one, which is the BIM to BIM project, which is an Irish funded project that it's aimed at producing an automated production of building energy simulation. So this is a summary, a very condensed summary of the IRIS group main interest. There are four main topics here. So we are interested in simulation of mainly energy simulation of buildings, all sorts of simulation, computational fluid dynamics, whole building energy simulation, and then also data-driven energy simulation. Second point is that we are very interested in the calibration methods. So both automated or both user input evidence-based calibration methods. By calibration methods, it's the procedure to change model parameters to fix the model more accurately to actual behavior of a building. We have a lot of expertise in the later years in the use of calibrated building models to support the operational stage of buildings. We can think about this point in two ways. There is it's called more mathematics-based smart operation of energy systems in buildings. So we are working in the smart artificial intelligence algorithm development, and we are particularly focused on energy systems and HVAC systems. We have a number of projects that developed fault detection and diagnosis techniques. We are particularly very good in Ireland. There are more Irish education institutions working in this field, and UCC, UCD. We have a lot of projects sharing partnership with them. Then we have the more administrative focus on the energy management and the operational side. So this is how to implement simulation to help support standardized energy management, ISO 50001, all these protocols for measurement and verification that support all these new energy services companies, how to measure savings against the standards. Then we have all this idea of using simulation to inform stakeholders, so building a framework for decision support, and then using also visualization of performance data. We have lots of projects where we have always the same problem of we're building a lot of algorithms, artificial intelligence, smart techniques that gather data and produce outcomes, produce analytics. But then we have the administrative side of things, so where there is a building owner, building asset managers that it's given a tool, very complex, very technical, and for the experience that we have of the previous projects and all the European projects that you can analyze in the background of these last years. Sometimes these tools, these kind of very technological tools, don't get used at the end. So we are trying to think about integration methodologies. So use data acquisition, manipulation, simulation tools, and front-end applications that are really fit for purpose to the end user, which is not really particularly keen on artificial intelligence or things like that. Okay. So what's the relationship between simulation and BIM? The simulation, if you are familiar with doing energy simulations, you will come across with this problem. Simulation has two main problems. First of all, simulation is time consuming. And if you have tried to produce a building energy model, you will notice that building energy models, they require a lot of input data, and they just take a lot of time to produce reliably. We all know that we have simplified tools, but if we are aiming to produce a more reliable building model, we can end up wasting a lot of time. Then there is another problem, which is uncertainty of data. So we are building energy models based on data that very often we just don't know. Maybe because the building is still not built, or maybe because we just don't have reliable information. So the main idea here is just using BIM. So BIM here is the main enable technology to produce reliable building energy simulations. These are just ideas of expressing the same idea, so the same concept. So BIM is a data repository that sits alongside the building life cycle, so it helps building energy simulation to have a more accurate data inputs. This is just to highlight that we at the Irish group are mainly focused on operational side, and we always try to do projects with real buildings and real data. Okay, these are some of the building demonstrators here in Ireland and internationally. You will recognize some of them. Okay, let's talk about the ongoing projects in the Irish research area. We can talk about 3 projects that are ongoing now. There is one project which is built to spec. This is just bringing BIM to the construction site. So you have here all the links. You can dig into the website. This is particularly a project that has a lot of information and that has a lot of stakeholder engagement strategies. So you'll find a lot of posts and a lot of information on Flipboard and on the internet. There is a lot of emphasis on using all sorts of artificial intelligence techniques, all sorts of key-enabled technologies like image recognition, drones, digital laser scanning on the construction site, so the building inspector or the engineer or the bricklayer or the whatever trade is on site can use a tablet and can use these techniques to assess the real execution of the building elements based on building specification. So that's the build to spec, okay? And it's the use of technology in the construction site. Heat2Gap is more on the operational side, so it's leveraging the last research projects on building simulation and fault detection and diagnosis. And we have also an Irish partner there in this project, which is Sutec. As I said, this is mainly focused on the operational side and on the HVAC efficiency and energy systems efficiency. And then the last one is BIM2BEN, which its main aim is how to generate automatically building energy modelings from building information management data. Okay? These are some motivations that we already all know. So there is a BIM steady growth market. There's still a slow adoption. There's some figures there from the UK last survey that you can consult. There is a lot of effort. There is the whole agenda in the UK. We will probably look forward in the next years to develop something similar in the Irish side. So there is a lot of efforts there and to develop all these standards for the interoperability, all the procedures, the data schemas, and so on. So what's the BIM and the BIM merge potential? We had this approach of these companies called Sutec. They have a very good value proposition. They sell a data management framework for facility managers and they use BIM data. They have had a lot of success in the last years, and they are a very international Irish company. But they have this whole repository of BIM data, so they were looking at ways of leveraging this data and try to implement a building energy module as a product. Okay. Then for us as academia, again the same idea of trying to get good models based on accurate data, which is always a problem. Okay. This is a presentation of the project. So these are it's funded by Enterprise Ireland. Sutec is the industry partner, and we have two other partners: University College Dublin and NUI Galway. As I said, the main goal is to develop a practical and sufficiently accurate energy simulation system which can be implemented quickly by architects and designers and is easy to use and to understand. The system should be fully integrated into Sutec's cloud platform, and there are two components. The system is as easy to use as in a tablet. Sutec data visualization platform is very, I wouldn't say simplistic, it's very easy to use, and it's very end user focused. So you will see all these demonstrations if you get in touch with them, and they have a lot of focus on easy and the easiness to use, and mainly all demonstrations are made in a tablet. There are two core components, this set of algorithms to transform all these unstructured that we were talking about before, data that comes from the Sutec platform in a variety of formats and ways of expressing data. We have also all sorts of data schemas, proprietary, non-proprietary, COVID spreadsheets, and so on. So you need a set of intelligent, ontological, or more structured methods to extract data from this database, and then to produce a simulation. And then there is the other main challenge here, which is the visualization of simulation results that integrated in the Sutec BIM platform. Again, the aim, so leverage the Sutec database and power data assets, generate building energy models from BIM data, the whole integration on the cloud database system framework that Sutec offers to their clients. This idea we'll explain later. Avoid the duplication of efforts when doing building energy modeling, and to produce an easy-to-use simulation generator versus a full simulation user input. So we're trying to reduce the amount of time is consumed into producing building energy models. This is done with some these are a few ideas to how to implement this easy-to-use simulation generation. So there is two main efforts here, which is the automation of the geometry input. So all the time that is wasted on to generating thermal zones It's automated using algorithms. And then to use easy to implement HVAC templates. So there is a whole effort on designing an algorithm to read data from the database, generate building energy zones, thermal zones, and then match the zones with HVAC systems. What's the ultimate value of this? Is to use building energy modeling into the design stage solution, and to use building energy model as to support this idea of performance-based contracting. This is still in the early stage, but what Sutex wants is to leverage the data assets to produce a building energy simulation that can be used also in the procurement stage. So we have all this idea, which is a bit new, of the e-procurement. Okay. I think this picture illustrates very well what's the idea behind the project. On the top part, we can see the usual workflow. So we have a variety of sources of information. We can have frozen data, so we can have data retrieved from paper from the design stage. We can have CAD data, which is more common, and also we can have a BIM model to produce a building energy model. Then there is, in the middle part, there is this energy modeler or engineer or whatever came the last to the practice to do the building energy model. For producing the energy model, we use normally architects or engineers third-party tools. So then starts the complication. So and there is this effort of you making assumptions, simplifications, all sort of decisions that involve informed decision or maybe not very well informed decision to produce the building energy model, and then to run the energy model and to analyze the outputs. This is time consuming and it has a lot of problems. For instance, the interoperability between the energy and the simulation engines and the third-party interfaces is not really clear 100% of times. So that means that you cannot modify things both ways in many of the platforms. Some of the platforms are embedded into BIM software like Revit or ArchiCAD, some of them not, and this process is not really straightforward and interpretable. What we're trying to do is to, let's say, minimize as possible the user interaction by offering them all the work done. So the core of the application will be the Sutex Emperor database, and the Sutex Emperor database is not really it's populated and it's created by BIM models that are produced beforehand. We are not dealing with BIM models at all. The BIM models are given to us in the Sutex Emperor database. This resides into a cloud application, and then the bin-to-bin application that also resides in the cloud produces the retrieves automatically building geometry information and creates the building energy zones, and then the user can match the zones to energy systems and produce the energy model. As simple as that. So for this we have these three main challenges. So we have the interface, we have the data mapping. So all sort of, I think the difficulty here it resides in how to develop algorithms that can read this unstructured data that sits on the Emperor database, and then how to assume and how to produce a simplified template-based energy simulation. This is a schematic of the workflow of the BIM2BIM project. It's not really 100% accurate. It's very difficult to do, but mainly there are two main focuses. So there are three work packages. Work package 1 focuses on the geometry data acquisition from the Emperor database, and work package 2 focuses on the HVAC systems. Then there's all sort of algorithms for merging the data and producing energy simulation. The energy simulation engine is Energy Plus, and finally producing the outputs for the user interface. This is just an illustration of what we are how we are implementing the software. So we are now in the stage of producing unit tests for HVAC simulations, and this is just the algorithm that validate the unit test. So we're producing exemplary or canonical building energy simulations, and then we're trying to replicate these energy simulations using the BIM2BIM application, extracting data from the database. Then we compare them and we see if the BIM2BIM project is fit for purpose as to what a building energy modeler will produce reading the database in a non-automated way. So this is more or less the workflow of the unit test. There are two fundamental developments in the project. One is is an XML schema to match and to match the Sutec data Emperor database, and then a sort of templates for HVAC generators, which is on this part side. Okay, I have a time notice here. So the good thing of the project is that once we have created the automated template generation template for the HVAC systems, it can be also, so the BIM2BIM platform can be also used to produce detailed building energy simulation, because the data and the parameters are there. What's the future? I will summarize this onto one point. So we're trying to get building performance simulation onto the whole life cycle, and particularly onto the procurement side of things. So we're trying to influence stakeholders to use building energy simulation to be used in the procurement stage, with this whole idea of performance-based simulation. Whether or not we will do it, it's a matter of years, probably. I don't know how many. But let's see. Thank you very much.